Hey everybody, welcome back. In today's video, we're going to talk about part 2 of how to factor. In part 1, we went through and we worked through all of these problems in the left-hand column here, and really gave you a lot of information at that point. Now what I'm hoping to do is be able to slow it down a little bit, just to give you a little bit more practice if you need to see some of that stuff just in a little bit slower pace. What I really want you guys to think about today is just what kind of problem we're working on and what are those steps. I really would encourage you to stop and pause the video and try a problem on your own and then see how far you can get. You've already seen me work a whole bunch of these, and really with factoring, the way you figure out this process is by going through and working it on your own. Let's start right here with this problem, x squared minus 5x minus 14. We're being asked to factor this. First thing we want to identify is which type of problem this is. This is what I would call an X method problem. Right, this is that most basic one that we have. The reason we know it's an X method one is because of the fact that the value in front of this x squared here is really just a 1. Right, if we don't see anything, we know there has to be a 1 sitting right there. As long as that's a 1, every one of these problems looks really easy like that. Now the negative 14 here is going to go into this slot, and the negative 5 is going to go into this slot. And then it's our job to find two numbers that multiply to be the negative 14 that are going to add to be the negative 5. Now, hopefully, we can think this out. Again, this is a great spot to pause the video and say, can I figure out those numbers? Because this is the actual math part of what we're doing right now. But those two numbers end up being a negative 7 and a positive 2. Once you have those numbers, then you can write out your factors. So 1 will be x minus 7. That, of course, came from right here. And the other one is going to be x plus 2, which came from over here. And this would be our final answer. Moving on to the problem below, we see that we have another one. Again, this is just an X method problem. The reason, because this is a 1. So if that's a 1, then we can come over here. We're going to put a negative 12 here and a 3 here. Right, the 3 comes from there, negative 12 comes from there. Two numbers that make this happen would be, well, none come to mind right now for me, so I'm going to sit there and make my list. So I just take my factor of 12. Again, don't worry about the negative. We'll deal with that in a minute. I know 1 times 12 is equal to 12, 2 times 6 is equal to 12, 3 times 4 is equal to 12, and 4 times 3 is equal to 12. Once I get to 4 times 3, I'm going to see my list start to repeat, and that's how I know I'm done. Now, thinking about those numbers, 1 and 12, one of those will have to be negative in order to make this work, but negative 1 plus 12 won't get me to negative 3, and if I switch that and make the 12 negative, that's not going to work either to get that bottom number. So it can't be 1 and 12. Those get crossed off. If we try 2 and 6, again, one of those has to be negative. Let's make it the negative 2. That would work for the top, but negative 2 plus 6 isn't going to work for the bottom. I can try to actually adjust those signs as well, and adjusting those signs for the bottom still wouldn't work. I would get a negative 4 and not a positive 3. So we're back to the drawing board yet again, but I do know 2 and 6 don't work. Last but not least, 3 and 4. 3 and 4, we got to make one of those negative. That makes the top work now. I always focus on making the top work first, and then we just check to see if the bottom works. Negative 3 plus 4 would give us a positive 1, so that's not the answer. If I go this other direction, positive 3 minus 4 would give us a negative 1. That's definitely not the answer either. And since we can't find any numbers that work for this, well, the only thing we're left with saying is that this is not factorable. And the reason we know that is because up here when we made this list, these were the only numbers that multiplied to be 12. There's no other numbers that multiply to be 12, and we looked at all those cases for positive and negative. Since there are no other numbers that are going to work to make the top work, then we know there's no chance of that bottom working either, so this is not factorable. Taking a look at another problem here. On this problem, we have x squared minus 3x minus 10. Again, this is a great problem for an X method because that a term is equal to 1. I'll have negative 10 here. You got to make sure you grab those signs every time. Two numbers that make this work, again, please feel free to stop the video and just see if you can come up with those. Those two numbers will be -5 and a +2, which means our factored form will be x minus 5 and x plus 2. Factoring becomes a really quick process when you know what you're doing and you've practiced it a bunch. If you're only just watching me go through these problems, but you're not getting a chance to practice on your own, you're going to find that you'll be struggling with this a little more. It's not a skill that's developed overnight. It takes a little bit of time. Here's another one. Again, I would call this an X method problem. I'll have -35 here, -2 here, -7 and a +5 are what are going to make that work. So I'll get an x minus 7 and an x plus 5. Again, pause the video, stop, think about these problems. Just copying down my work is not going to mean you're getting better at these. This is a unique one, ladies and gentlemen. At the end of part 1, we talked about our steps down here at the very bottom. We gave you this little cheat sheet down here. And what the first step of that cheat sheet really says to do is it says remove the greatest common factor and make the first term positive. Now, if we're thinking about those two steps, making the first term positive and removing the greatest common factor, looking at this problem, we can see how this is really a -1 sitting right here, and it's not okay for that first term to be negative. So we got to actually pull that -1 out of each of those terms by factoring. So if I factor that -1, this is another form of factoring. It's called pulling the greatest common factor. Pulling out that -1, I'm going to get an x squared here, minus 2x minus 48, right? It's like dividing each of those terms or those coefficient values by that -1. Now, as soon as we get to here, we notice that what's left inside is just our normal x problem, our x method. So we can go straight into our x. We'll put a -48 up top and a -2 on the bottom. Two numbers that multiply to give us a -48 that add to give us a -2, I believe are -8 and a +6. So that means that this can factor down to be x minus 8 and x plus 6. Now, one thing you got to be very careful of is we can't go and forget about that -1 that we've already factored out. That still needs to sit in front to ensure that this all multiplies out to get back to our original. Here's where we get back into those difference of perfect square problems, right? Again, if you notice here how this is negative and this is negative, we're going to have to factor out that -1 before we can do anything else. So factoring out that -1 out of each of those terms would leave me with x squared minus 1. And if I do the same to the bottom right now, kind of working two problems at once, we'd be left with 81x squared minus 36. Now, these problems are normally pretty easily identifiable because there's only two terms. So when you see those two terms, you really want to check and think to yourself, is this a difference of two perfect squares? And as soon as you can say, yeah, each of these terms is squared, it's just a number squared, then you can come over there and quickly rewrite this. Remember the pattern, one will be positive, one will be negative, and then it's the square root of each, right? The square root of x squared is just x, and the square root of 1 is just 1. So we get a +1 and a -1, and you just can't forget about the -1 that sits right there. Moving down to the bottom of this, again, we've got to this point where we factored out that -1. As soon as we've identified that this is a difference of two perfect squares, I get a plus and a minus. The square root of 81x squared has to be just 9x. And the square root of 36 is just 6. Now, one last thing to consider here. Whenever we factor, we always want to use the terminology of factor completely. Pull out anything we can. So we should always look back at our terms here and say, is there anything else that can be pulled out of this? And in fact, when you look at this, it does look like I could pull a 3 out of both of those terms and a 3 out of both of these terms. So if I were to actually factor that, I would have negative 1 times 3 times 3x plus 2, and then times 3 times 3x plus 2, right? I've pulled that 3 out of each of those two terms and kind of placed it in front. Now, these numbers are all basically the same here, same kind of number. Those can all be multiplied together, so I will have a minus 9 sitting out front, and then I'll have 3x plus 2 times 3x plus 2. Now, that's a little unique. We haven't really seen that just yet, but I want to just take you back to the original for a second. At the beginning of this process, after you've seen that little flow chart of what we do, it says remove the greatest common factor and make the first term positive. Really, we're saying if possible. And in fact, in this problem, there is a greatest common factor between 81 and 36, and that number is 9. So I can pull a 9 out of this. Another way to think about this problem would be to pull a 9 out of each of those terms right away. And not even just the 9, let's pull a negative 9 out so that that first term becomes positive. If I pull a negative 9 out, I'll be left with 9x to the second power. And I'll have plus, if I pull a negative 9 out of that second term, I'll be left with a minus 4. Now I am seeing one mistake I made before. We'll come back and catch that in a second. But I'll have a minus 9 here. And then realizing that this is just a difference of two perfect squares, I'll get 3x plus 2 and 3x minus 2, right? Which is basically the same answer we have, except on the last problem, I dropped my negative sign. So right there I had a negative. Here I changed it to a positive. That's not okay. So I'm going to go back and correct that right now. Now our two answers are both the same. Now, it does look like the second way we did that was much easier than the first, and that's okay. Sometimes you're going to notice those patterns and see those things. Other times you got to catch them later. Factoring is all about getting it right at the end. Let's look at a couple more of these. Now we're dealing with problems where our A value is greater than 1, but that A cannot be factored out of everything, right? So whenever I see an A value that's bigger than 1, I always think to myself, well, can I pull it out of each of these terms? And really, while I could pull it out of 2 of these, I can't pull it out of this guy. And since I can't pull it out of that guy, we are not allowed to go further down that road. This will not work. Instead, we are left with an X box problem. Remember, for an X box problem, there is one additional step right here where you have to multiply 6 times negative 6, and that is what will give you your number up top. That's our negative 36. Our negative 5 still comes from the same place, is going to go right down on the bottom. Now we're looking for two numbers that make this work. I'm not thinking those, I can't think of those two numbers off the top of my head, so this is where I'll make my list. 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9. 4 and 9 got to be my guys, right? So 4 and 9. Let's make the negative 9 there because that will make sure we add to the negative 5. Now, again, the X part is complete here. Now we need to do the box. So the box is really the biggest step you need to remember on these problems, along with this additional multiplication. Now, once you have the box drawn, you just need to put numbers in the right spot. So this 6 will always go in this spot. This last number here will always go in this spot. This 4 will always go in this spot, and this negative 9 will always go in this spot. Test yourself. Make sure you can always figure out where those numbers go because that's part of getting this right. Now we are going to look for a number or a greatest common factor that can be pulled out of these two terms. The biggest number I can pull out of 6 and 9 would be a 3. And then I ask myself, 3 times what is equal to 6? Of course, this is a 2. They were just doing what we call an area problem right now. And 3 times what is equal to negative 9? This, of course, has to be a negative 3. And last but not least, 2 times what is equal to 4? This has to be a 2. And then I can check, does 2 times 3 equal a negative, or 2 times negative 3 equal negative 6? And our answer is yes. Now, right there, we have our factors. So we know one of our factors will be 2x minus 3, and our other factor will be 3x plus 2, since that 2 was positive. Of course, we want to write those nicer. 2x minus 3, and we're going to get a 3x plus 2. And we're done. Nice job. Let's take a look at another one here. Now, again, anytime I look at a problem, my first thing has to be to look for a greatest common factor or to make sure that we're turning that first term positive. Our first term is already positive here, but there is a greatest common factor that can be pulled. The reason I know that is because each of these is even. That means I can pull a 2 out of each of those terms so that now I can rewrite it as 5x squared plus 22x plus 8. I just want you to think about this for a second. If you didn't pull that out, you're going to be dealing with a big multiplication there of 10 times 16, and that's going to give us some trouble. Notability froze 1 second. Now, looking back at this, when we reevaluate the inside here, we do notice that this is still an x box problem. We've not eliminated that 5 that's in front of the x squared, so we need to do the x box method. Now, again, to do the x box method, you need to first multiply your a and your c terms. What I always tell students to do is kind of just to forget about that 2 for a minute, right? Once you factored out that 2, this really is no longer our starting problem. This is where we're at. So I always tell them to scribble that out too, so when they're making their box, they're not pulling numbers from the wrong place. 5 times 8 gives us a 40 up top. And then on the bottom, I'm going to get my 22. Now, two numbers that multiply to be 40 that add to give us 22 would be 20 and 2. We've done the x. Now we got to do the box. Again, great time for you to pause the video and try to put those numbers in the appropriate spot. We know that this 5 goes up here, this 8 goes down here, this 20 goes right here, and this 2 goes right here. Now we think about a greatest common factor that can be pulled out of 5 and 2. There is, of course, no number that divides into 5 and 2, so we can only pull a 1 out. If that's a 1 on that side, then 1 times 5 gives us that area of 5 on the inside, and 1 times 2 gives us that area of 2. If I know that this length of the box here is 5, then this would be 5. 5 times what is equal to 20? Well, that is, of course, 4. And then we check, does 4 times 2 equal 8? And it does. So we know that our two terms are going to be 5x plus 2, right? It's positive 2. I just put my x in there. And 1x plus 4. So 5x plus 2 and 1x plus 4. If you get to a test or a quiz and you really want to check yourself, don't be afraid to go and actually distribute that back out. That is how we check, is really just to come over here and to re-multiply all of this out. Looks like we have 2 more problems to tackle. First thing I look for, first term is positive, that's a plus. I also want to say, is there a greatest common factor here? And there is not. So since there is not a greatest common factor, we know that we have to do an X box problem. So my first step is 5 times negative 6, that's negative 30. I'm going to get my negative 7 on the bottom. Two numbers that multiply to be negative 30 that add to give us 7 would be a negative 10 and a positive 3. I've done the X, now we got to do the box. When you get really fast at doing the box, you kind of just can throw your numbers in there quickly. There is no greatest common factor between 5 and 3, so I'm going to pull out a 1, which means this is a 5 and this is a 3, and this has to be a negative 2. Negative 2 times 3 does equal negative 6, so my factored form is 5x plus 3 and 1x minus 2. Now what I will tell you, everybody, is you don't need to factor my way. but my way typically can get you answers much quicker than the guess check process that you've maybe learned in the past. And while both of them work, that's what I'll stress all day long. You're good to use either one. Just make sure you have a process. If you're seeing this and you're like, man, I think I'm close on this, I just have questions, just make sure you're reaching out and asking. Last problem we see here, 10x squared minus 26 minus 12. First term's positive, good news. Second thing we look for, is there a greatest common factor? Of course there is. 2 goes into each of these, so if I pull a 2 out, I'll be left with 5x squared minus 13x minus 6. Again, drop that 2 all the way down to where your final answer is going to sit. This is, I scribble out that top one too. As soon as I factor that out, I don't want to go back to that original equation again. This is an X box problem. So I will distribute from here to here, or not distribute, multiply. Kind of the same thing. I'll have a negative 30 as my top number and a negative 13 as my bottom. This, of course, will be a negative, thought it was a negative 10 and a negative 3, but that wouldn't work. How about a negative 15 and a positive 2? The 5 goes here. The negative 6 goes here. The negative 15 goes here, and the positive 2 goes there. Again, no greatest common factor to pull out here. That happens sometimes, which means this is 5 and this is 2. And this must be a negative 3, and that does in fact check out, so we're good. Making my final answer 5x plus 2 and 1x minus 3. Last but not least, that's kind of why I draw this line down. Don't forget about that 2. That has to sit in front as well. Otherwise, we are not factored completely. Great job, ladies and gentlemen. Again, if you have a different way to factor, that is fine. Use that way. If you need a little bit more clarification on this, don't be afraid to reach out and we can go over some more problems together. Thanks for taking the time to watch this video. I hope it was worthwhile to you. Have a good day.